Okay, the subject matter for this week is going to be nodal analysis, also called the node voltage method. This is one of two methods that is used when there are many unknowns in a particular circuit, when you have to determine many voltages or many currents. The other technique is called the mesh analysis, or a mesh current method. Unfortunately, we're not going to take mesh analysis in this particular course. We're only going to take nodal analysis. We're going to take nodal analysis very slowly. The concepts are quite simple, but I'm going to be giving a lot of examples. It's very important that you master nodal analysis, that you understand it very well, you understand the concepts behind it very well, because this is what you're going to use in most of your circuit analysis from here until the end of your EEE days. You're going to come back to nodal analysis time and time and time again, so you should understand it very well. Okay, so let me share my screen. Okay, so this is a summary of what we're going to take up today. Okay. So I'm going to give you an introduction to nodal analysis. Then I'm going to give you the general procedure for nodal analysis. We'll take up some examples after that. And then after that, I'm going to take up one special case with you. And that is what happens when you have what is called a floating voltage source. And then on Thursday, we're going to take up two other special cases when you have controlled sources and when you have floating controlled sources. Okay, nodal analysis is a systematic method of analyzing circuits which reduces the number of simultaneous equations needed to solve for all required circuit quantities. Typically, the number of simultaneous equations needed would be the number of essential nodes minus 1. So if you have, let's say, 4 essential nodes, you would only have to solve 3 simultaneous equations. Okay. Now, this is based on the fact that the current flowing through any resistor in a circuit can be expressed in terms of the node voltages. Let me give you an illustration of what I just mentioned. So this is the example that we took up last Thursday. If you recall, if you take a look at your notes last Thursday, we took up this circuit where we had 6 unknowns. What were our 6 unknowns? You had I1, I2, IX, I3, I4, and I5. 6 unknowns. The known quantities in your circuit are your sources. So you have your 8 ampere source, you have your 10 volt source, and you have a controlled source for IX. So the current flowing here is 4 times the current flowing through your 30 ohm resistor. Now, how many equations did we form to solve this? So remember the rule. If you have n essential nodes, then you can only form n minus 1 Kcl equation. So here I have 4 essential nodes, A, B, C, and D. I had 4 essential nodes. So I can only form 3 independent Kcl equations. But I have 6 unknowns. I have 6 unknowns. I can form only 3 Kcl equations. Where do I get the remaining 3 equations? The remaining 3 equations, I apply KVL on my meshes. So that's what I did. So I applied KVL to this mesh, and this mesh. And that's where I got my 3 other equations. So I had to solve for 6 equations in 6 unknowns. Now, everybody knows that that's not a very nice, or it's not a very convenient thing to do. Fortunately, your calculators can solve sometimes up to 3 or 4 equations in 4 unknowns. If you go in the internet, you're going to find equation solvers there that can solve a set of linear equations in more unknowns. But if you had to do it by hand, you wouldn't want to be solving more than 3 equations or 4 equations in 4 unknowns. In this case, you needed 6 last time. Okay, if we let VA, VB, and VC be the voltages assigned to nodes A, B, and C respectively. No? So this is VA, the voltage at this node, VB, the voltage at this node, VC, the voltage at this node. Now remember, voltages are always with respect to 2 points. No? So when you say voltage at a node, that's always with respect to a reference. And in this particular case, what we assigned as our reference was node D. No? So the entire bottom here, this is node D. We assign this to be our reference node. By making this the reference node, all we are doing is saying that VD is equal to 0. Okay. Another way of indicating that this is our reference node is linalagyan natin ng ground symbol. When you see this ground symbol, that indicates now that that is your reference node. Okay. So we let VA, VB, VC, the voltages assigned to nodes A, B, C with respect to node D. And I maintain that all unknown currents now can be expressed in terms of VA, VB, and VC. I pick up any unknown current here, I should be able to express it in terms of VA, VB, and VC. No? For example, I1. What is I1? No? So this is I1. I can express this in terms of VA and VD. I1 is equal to VA minus VD divided by 10 ohms. That is, the voltage across this resistor is VA minus VD. That's the voltage across this resistor. Divided by its resistance, that should give me the current. That is just Ohm's law. But take note, VD, we said that VD is equal to 0 because this is our reference. So this is just equal to VA over 10. Okay? Who can give me an expression for I2? Can someone help me? No? What is our expression for I2? Anyone? Or should I call out someone at random? Sigaw na lang nyo, no? Whoever wants to answer.
Sir, VA minus VB over 20 ohms po.
That's right, no? VA minus VB over 20. Why is it VA minus VB and not VB minus VA? Same person.
Sir, kasi po yung kinukuha po natin is yung yung sa V po na resistor, kaya una po yung VB. Same way kanina po nauna yung VA from that node po.
Yeah, again, no? What's your expression for I2?
Sir, VA minus VB po.
Oh, bakit nauna yung VA?
Yung direction po ng current.
Okay, exactly, no? The direction of the current, no? The direction of the current implies that the left terminal is of a higher potential than the right terminal, no? Kasi this is a passive device, no? So by passive passive sign convention, we know that the current will flow in the direction of decreasing potential. So it has to be VA as answered. This is VA minus VB all over 20 ohms. So that's the value of I2. Okay? What about someone, no? Ice of X. Anong value ng Ice of X? Or express Ice of X in terms of your node voltages. Can I call on Kcl Dino?
IX is VB minus V over 30 ohms.
VB minus
VD.
VD. Yeah. All over 30 ohms. But what does this simplify to?
VB over 30.
Yeah, VB over 30. Okay. So you see, it's very simple, no? Now take note that these directions of currents are arbitrary, no? We just assign them. If you don't know the direction of the current, you assign a direction of current, no? What would have happened if the direction of current, for example, here in I2, the direction of current that I assigned were this way? No? If this is the direction of current, no, then what would I2 be? I2 would be VB, kung ito, no? Kung ito, I2 would be VB minus VA over 20. If the direction of current were from right to left. No? But that's okay, no? Because when we now do our KVL, the polarity of the voltage would be opposite if we had done our KVL. And you're going to get exactly the same result. Okay. So it depends on your assumed direction of current, no? So I can fill this up very quickly, like I3. I3 will be VB minus VC over 40. I4 would be VC over 60, no? Because VC minus VD. Okay, what about I5? Who can tell me what I5 is? Can I ask Albert Castillo to try? Ano yung value ng I5?
VC minus 10 volts.
That's right, no? I5 is over what? Sorry, VC minus 10 over
50 ohms.
Okay, no? I5 is VC minus 10 over 50, no? Because if you take a look at this is not an essential node, no? This is a non-essential node, but there is still a node voltage there. The node voltage there with respect to D is equal to 10 volts, no? That is the node voltage. The node voltage at this point with respect to D is constrained. We call it constrained by this voltage source. This voltage source establishes this node, this particular node voltage. So when you express I5 is VC minus 10 divided by 50. No? So all my unknowns can be expressed in terms of VA, VB, and VC. So for me to solve for all my unknowns, all I have to do is solve for VA, VB, and VC. No? Kung alam ko yung VA, VB, VC, lahat ng kailangan ko malaman dito sa circuit na to, pwede ko nang malaman. All of my currents now I can determine. So what I have to do, I have to look for a set of equations, no? 3, as a matter of fact, I have to look for 3 equations kasi tatlo yung unknown ko, VA, VB, VC. I have to look for 3 equations that I can solve simultaneously. And these equations now can be formed using Kcl. Okay. Those 3 equations can be formed by using Kcl, and that is the node voltage method. So I'm going to give you the general procedure. Ano yung general procedure? Okay. First, you label all essential nodes in the circuit. Second, if you don't have a reference node yet, kung walang designate, no? Kung walang designated reference node, select a reference node, no? Quote unquote a ground, and we can choose any node to be a reference node. But later on, you're going to see that some nodes are more convenient to assign as reference nodes than others. Yung choice ng reference node is arbitrary, but some are more convenient to be assigned as reference than others. For example, in this example, this is a nice reference node kasi ang daming nakakabit na components dito sa node na to. No? Remember, this is only one node. Take a look. There are 1, 2, 3, 4, 5 components connected to it. Now, why is it nice to have that as a reference node? Because now, the voltage across those components need only to be expressed by one variable. So again, no? We choose a reference node as our second step. Okay, we assign a node voltage variable to each of the remaining essential nodes. So, meron tayong isang reference node, dun sa mga natitirang node, we assign a voltage variable, and that is the voltage at that node with respect to the reference node. What is the fourth? The fourth, identify the node voltages which can be determined by inspection. Okay. Important step to, number 4, identify the node voltages which can be determined by inspection. Number 5, for the remaining essential nodes, no? So, yung mga nodes na yung voltage hindi ma-determine by inspection, those are your remaining essential nodes. Write the appropriate Kcl equation with currents expressed in terms of node voltages. So if I go back to the previous example, we did that. All the currents we expressed in terms of node voltages. Then we solve the system of equations, and then finally solve for the required quantities from the node voltages. So this is the general procedure for the node voltage method, or nodal analysis, as other books call it. Okay, so let's take an example. So the example is find the voltage Vx using nodal analysis. Vx is the voltage across my 30 ohm resistor. I want to find that voltage, and I'm going to use nodal analysis. Okay, so what is the first step? Label all the essential nodes. That has already been done, A, B, C, and G. I have 4 essential nodes, A, B, C, and G. Okay. The next step, designate a reference node. So meron na tayong designated reference node. That is node G. The next step, assign a node voltage variable to each of the remaining essential nodes. So I'm going to assign, okay, this is my reference. So dun sa mga natitira, I assign a node voltage variable. Okay. So what are my node voltage variables? That's going to be VA. Let me just put it here. VB and VC. So those are my 3 node voltage variables. Okay. Let's take a look at the next step. Identify the node voltages which can be determined by inspection. Okay, I want you to take a look at this circuit. Is there any node voltage that can be determined by inspection? Can I ask?
Sir, is it yung sa VA and VB kasi there's a positive, because current flows from positive to negative sa VX.
Who's this, Ryan?
Yes po.
No, what about VA and VB? Sorry, again.
By inspection, is it possible that you can get VX through VA minus VB over 30 po? Kasi you can determine the current.
That's your expression for the current, no? Dun sa step na to, identify the node voltages which can be determined by inspection. So we have 3 node voltages, no? VA, VB, and VC. Can I outright identify that any one of these node voltages can be determined by inspection?
Oh yes po. Is VA 4.8 volts?
That's right. That's right, no? Right away, I can see that VA is equal to 4.8 volts. No, because I put a 4.8 volt between node A and ground, and that immediately constrains the voltage at VA. Whenever you put a voltage source between a node and ground, then that will already constrain the voltage at that particular node. No? In other words, it doesn't matter what the rest of the circuit is, that node will be pegged at 4.8 volts. So right away, dito sa step 4, right away, we know that VA is equal to 4.8 volts. So actually, we now only have 2 unknowns. No? So there are only 2 unknowns, VB and VC, because we already know VA. Okay? And so what are we now supposed to do next for the remaining essential nodes? No? So we already know VA. So for the remaining essential nodes, we're talking about node B and node C. Write the appropriate Kcl equation with currents expressed in terms of node voltages. Okay, what is my Kcl expression at node B? Okay, Kcl at node B. Okay, the usual convention is we assume that the currents are flowing away from the node, no? Unless the current is already fixed by some other means. No? But the usual convention is we assume the currents are flowing away from the node. So we have 3 currents flowing away from VB, this is one current, this is another current, and this is another current. No? So what is my expression for this current? Can someone tell me what the expression for this current is? Anyone? Can I call on Clyde? What is the expression for this current?
VB minus 4.8 volts over all over 30 ohms.
That's right, no? VB minus 4.8 volts. Okay, actually it's VB minus VA, but we already have established VA to be equal to 4.8 volts. So that's VB, no, minus 4.8 volts over 30, no? So that's in this direction. What about this current? No? So I'm doing KCL, so that's plus. What is this current? No? So that's trivial. That's VB over 15. No? And then what about this current? Okay. Joseph Cano. Ano itong current na to?
VB minus VC over 10 ohms po.
So that's VB minus VC over 10 ohms, okay, is equal to 0. Equal to 0. So I have three currents, this way, this way, this way. This is my first current, this is my second current, and this is my third current. Okay, question, no? What if, so madaming what ifs to, no? What if I had assumed this current were this direction? Okay. What if I had assumed that current was in that direction, no? So it's going to be, my expression is going to be this current plus this current minus this current, no? Kasi ito palabas, pero ito naman papasok, no? So this term is going to be the same. This term is going to be the same, but what is my third term going to be, you know? So anyway, let me write this is going to be the same plus VB over 15. What is my third term going to be? First of all, it is going to be minus. Minus, no? Kasi papasok to. Now, what is my expression for current? Clyde, ano yung magiging expression ko for the current?
Since minus po yung harap, I think it would be the same po. VB minus VC over 10.
No. Note, no, your current is going from right to left. So what is going to be my expression for the current, no? If it's going from right to left?
Okay, ano po? VC minus VB na po.
Yeah, that's right, no? So this is going to be VC minus VB all over 10, no? Is equal to 0. Notice that these two are the same. No? Notice that those two are the same. That's why I was telling you, you can arbitrarily assign, if you don't know the direction of current, you can arbitrarily assign any direction. And as long as you're consistent in the way you express the voltages, no, the way you express the currents in terms of the voltages, you're going to get exactly the same equation. Okay, so this is KCL for node B. No? Now, what about my KCL for node C? Let me just do that, no? KCL for node C. Gawin ko na lang dito, no? Okay, so what currents do I have? I have ulit, no? I can now change my assumed directions of current. I can say this current. Ito wala tayong choice, no? This current is this way, no? And then I have also this current up here. Okay, ano itong current sa taas? flowing out of the node dito sa taas? Can I hear someone else? Can I hear Mr. Norio? What is this current?
VC minus 4.8 volts over 40 ohms.
Yeah, that's right. VC minus 4.8 volts over 40. Okay. Then let me just continue. No, I think everybody already gets the hang of it. So this is plus VC minus VB over 10. Okay. Plus VC over 20 minus 2. This is 2. So minus 2. Why minus? Because it is flowing inward. Now, I cannot do anything about the direction of current here that is established by the current source. This is equal to 0. So 2 equations, 2 unknowns. Actually, 4 essential nodes. So dapat 3 equations, but 1 essential node has a voltage that can be determined by inspection. And therefore, I only had to apply KCL to this node and this node. No? Okay, so 2 equations in 2 unknowns, VB and VC. And so now this just reduces to a math problem. Okay, if you solve for this problem, you're going to get, okay, so solving simultaneously, I'm going to get VB, let me just give you the answer, is equal to 2.4 volts, and VC is equal to 3.2 volts. Okay, but actually, ang yung original problem natin, our original problem was determine V of X. So what is V of X? No, V of X is really VA minus VB. So it's 4.8 minus 2.4. So the answer is 2.4 volts. Okay. So I was able to, I can actually now solve for any quantity I need to solve for in the circuit because I know the value of all of the node voltages. There are how many resistors here? There are 1, 2, 3, 4, 5 resistors. And then you have 5 resistors. If my unknowns were the currents across flowing through each resistor, I would have had to set up 5 equations. But now I was able to do it with only 2 equations, solving for all the currents in the resistors with only 2 equations. If my unknown is the current supplied by the 4.8 volt source, it's easy for me to do that because I can now apply KCL here. No, I know the current flowing through the 40 ohm. I know the current flowing through the 30 ohm. So by applying KCL here, I can now get the current supplied by my 4.8 volt source. In the same way, I can get the voltage across my 0.2 ampere source because I know now the current flowing through here. Okay, and I know the voltage across my it's staring at you in the face. The voltage across my 0.2 ampere source is already V of C. Because that 2 ampere source is connected between V of C and ground. Are there any questions with regard to this example? Ano yung 2 or 0.2? Sorry. You're right. No? Thank you very much. No, for pointing that out. This is 0.2. 0.2. Sorry. Okay. Any other questions? Any other questions? Okay, here's an exercise. Derive an expression for V of O in terms of V1, V2, and V3, and the conductances of R1, R2, and R3. Now, this is a specific purpose circuit. This is called a weighted average circuit. And the reason for it being a weighted average circuit, you're going to see in your expression. Okay, so this is very straightforward. Okay. How many essential nodes do we have in this circuit? Anyone? How many essential nodes do we have in this circuit? Sino ba hindi ko pa naririnig? Any volunteer? Somebody said three essential nodes. Somebody said one. Okay, there are. Ano yung definition natin ng essential node? An essential node is a node where more than two elements are connected. No? A node where more than two elements are connected. So if you take a look at this circuit, there are only two essential nodes. Let's see what the others mentioned. Yes, that's right. Ano? Si Nika and Clyde, there are only two essential nodes. No? So this is one essential node, and this is another essential node. In which case, how many nodal equations can we form? No? Remember, if you have n essential nodes, you can only form n minus 1 nodal equations. So I can only form one node voltage equation here. Okay, so this is my one essential node, and this is my other essential node. What is the first step? The first step is to designate a reference. Actually, the first step is to designate to designate variables and then to assign a reference node. No? But actually, itong node voltage dito, if you notice, the node voltage there is actually V sub O. If this is my reference. No? If this is my reference, the voltage at this node is V sub O. Okay. Now the thing, what do I have to do next? No? What I have to do next is apply KCL to this, no? Because I don't know what V sub O is. I cannot determine V sub O by inspection. No? There's no way I can determine V sub O by inspection. So this is unknown. So I have to apply KCL here. No? If you know the node voltage, you don't have to apply KCL. No? It's when you don't know the node voltage that you apply KCL. Okay. So I have three currents here. These three currents. Okay, what are my expressions for those three currents? Fortunately, I know the voltages at these particular nodes. The voltage at this node is V1, the voltage at this node is V2, and the voltage at this node is V3. These are non-essential nodes, but I know the node voltages, no? Because that is established by these sources. So what is now my KCL equation? Okay, my KCL equation is going to be V sub O minus V1 over R1. Okay, that's this current plus V sub O minus V2 over R2. That's this current plus V sub O minus V3 over R3, that's this current, is equal to 0. Equal to 0. Any question? Any question with regard to this expression? Okay. Malinaw, no? It's very clear. Okay, so let me simplify this further. Okay, I'm going to have, sorry. Okay, I'm going to have V sub O multiplied by 1 over R1 plus 1 over R2 plus 1 over R3. Okay, so what did I do? No, I just factored the coefficients of V sub O, no, from each of the terms, no. So that's V sub O 1 over R1 plus 1 over R2 plus 1 over R3 is equal to V1, okay, multiplied by 1 over R1 plus V2 multiplied by 1 over R2 plus V3 multiplied by 1 over R3. Right? So itong mga terms na to, lalagay ko sa kabila, I put the other side of the equation. So this term is V1 over R1, this is V2 over R2, this is V3 over R3. I just put it on the right side. So notice now this is V sub O. 1 over R1 is G1, 1 over R2 is G2, 1 over R3 is G3, and that is equal to, sorry, this is V1. V1 G1 plus V2 G2 plus V3 G3. Or V sub O is V1 G1 plus V2 G2 plus V3 G3 all over G1 plus G2 plus G3. Now this is a weighted average circuit. Can you give me an example of a weighted average? What do you normally compute for at the end of each semester? Ano yung kino-compute ninyo? Anyone? Para hindi kayo makarelate sa weighted, or I'm sure you can relate to weighted average, no? What do you normally compute for? That's right, ano? GWA, no? Ano yung grade weighted average, ano? So what is your grade weighted average? Okay? Ang katumbas ng V1, let's say VI, is your grade in subject I, no? Tapos ang katumbas ng GI is the number of units. Right? So if you have 3 subjects, ano yung GWA mo, no? If you have 3 subjects. Okay, you have V1 G1 plus V2 G2 plus V3 G3, no? That's your grade multiplied by the number of units all over your total number of units, no? So notice that that is your weighted average. Okay. So that's why you call this a weighted average circuit. It's a very simple circuit. Okay. Okay, here's an exercise. The node voltages in the circuit shown are VA equal to 7 volts and VB is equal to 10 volts. Solve for the values of the current source I sub S and the resistance R. No? Well, here's what I'm going to do. You should be able to solve this in just a few minutes. Try to solve this. No, I'll give you 5 minutes. Try to solve it. Okay, and then if you get the answer, tell me the answer through the chat box. Yung mga hindi pa nakakasolve, huwag niyo muna titignan yung chat box. Ano? Okay, so let's do that. I'll give you the next 5 minutes. Please try, ah. Baka yung iba, ano, no? Tamarin. Please try. Does anyone have an answer already? Lapa? What is the value of R and what is the value of I of S? Please use the chat box. Lapa? Okay, I'm starting to get I'm starting to get some responses. Okay, I think I've had enough responses. Okay, the correct answer is R is equal to 4 ohms and I of S is equal to 4 amperes. No? So, medyo a number of you got it right. No? Albert, Janica, Clyde, you got it. You all got it right. Nice try, Joseph. No, I appreciate that you tried. So actually, how many essential nodes are there? There are 3 essential nodes. No, this is one essential node, A, B, and the other essential node is your ground. Okay, but we designate this already as our reference, and therefore we only form 2 Kcl equations. One Kcl equation for this and one Kcl equation for this. Ano? If you form your Kcl equation for this, okay. So what are your currents? This is these are your currents. This is one, this is another, and this is another, and of course this one. No, this one is 2 amperes already. Okay, so what is Kcl at A? Okay, you have VA over R plus VA over 4 plus VA minus VB over 2 minus 2 is equal to 0. And then you just plug in. VA is 7, VB is 10. Okay. So simply plug in. You only have one unknown. So with VA equal to 7 and VB equal to 10, you're going to get R is equal to 4 ohms. And then if you apply KCL at B, okay, so ang mga currents naman natin are this, and this. So this is I of S. Okay, so you have VB minus VA over 2 plus VB over 8 plus VB, another VB over 8. Actually, if you notice, these 2 resistors are actually in parallel. No? Actually, all of these resistors are actually in parallel. No, sorry. No. These 2 are in parallel, and these are also in parallel. But not all of them are in parallel because of these 2 amperes. But anyway, VB minus VA over 2, VB over 8, another VB over 8, minus IS is equal to 0. This particular case, the same values here, you're going to get I of S is equal to 4 amperes. So very straightforward. Okay. Now we're going to take up one complication of using the nodal analysis or using the node voltage method, and that is when you have a floating voltage source. No? A floating voltage source is a voltage source that exists between 2 nodes neither of which is the reference node. So in this particular example, this is called a floating voltage source because it is applied across two nodes, node B and node C, and neither node B nor node C is your reference node. Now, why is this going to cause some complication? Okay, for the circuit shown, we'll take this example. For the circuit shown, determine the voltages VA, VB, and VC using nodal analysis. So we have 4 essential nodes. One essential node is made your reference or ground, and therefore you only have 3 unknowns, VA, VB, and VC. Okay, yung KVL for node A is straightforward. No? KCL rather. KCL can easily be applied to node A. No? Okay. So what is my KCL expression for node A? Okay, I'm going to ask someone to do this for me. Can I go back to Clyde? What is my KCL expression for node A?
Negative 3A plus VA.
Hindi mo na makita? Sorry.
Hindi na po.
Okay, sige. Negative 3A.
Plus VA minus VB all over 6 ohms. Plus
VA minus VB over 6 ohms. Okay.
Tapos plus VA minus VC all over 8 ohms po.
Minus VC over 8 is equal to?
Is equal to 0 po.
Is equal to 0. Don't forget that, no? So straightforward, no? Straightforward. I can apply KCL to node A. By the way, no? Remember, the one step is determine whether any node voltage can be determined by inspection. There's no node voltage here that can be determined by inspection. No? So obvious yun, no? So tama, no? This is my KCL equation. So minus 3 VA minus VB over 6. Okay. VA minus VC over 8 is equal to 0. Okay. Okay, next question. Can I apply KCL to node B? Does someone want to give it a try? Apply KCL at node B. Anyone? Or if you cannot apply KCL at node B, tell me why, no? Either you give it a try or tell me why you cannot do it. Can I call on Ryan again?
Sure. Is it that we cannot do it because there's no resistance there's no resistor by the 6 volts? Or because I'm not too sure, Paul.
Okay. Yeah, you have the right idea, no? What do you need to form a KCL equation? You need currents, right? You have the right idea, no? To form your KCL equation, you need currents. So if I want to form a KCL equation here, okay, I need this current, and I also need this current, no? But I don't know what this current is. No? Therefore, if I form a KCL equation at node B, I would be introducing a new unknown, no? Okay, so the way to state it is you cannot apply KCL at node B without introducing a new unknown. No? A new unknown. And that unknown is the current supplied by the 6-volt source. No? The current supplied by the 6-volt source. So maybe I can call this I 6 volts. No? So I can apply KCL at node B, except that I'll be introducing a new unknown. Now, if you have a new unknown, what does that mean? That means you need another equation. You need another equation. Remember, what we want to do in the nodal analysis is we want to reduce the number of equations that you use. So I cannot. Okay, let's try some other way. No. By the way, same thing here with node C. No, same situation with node C. If I were to apply KCL at node C, I would have to include the current here, which I don't know. Okay, so what is my solution? Okay, here is my solution. No? I am going to define this as what is called a supernode. I'm going to define that as a supernode. Okay. In fact, if it is a supernode, I don't even have to know what's inside that. I can even hide the inside of that. No? And then I can apply KCL to the entire supernode. Apply KCL to the entire supernode. Why can I do that? No? All the currents flowing into a supernode should be equal to all the currents flowing out of the supernode, or the algebraic sum of all currents leaving a supernode should be equal to 0, because a supernode is like a node. It is not capable of accumulating current. It has no current storage capacity. In other words, all the charges that enter must be equal to all the charges that leave. That is a supernode. So I can combine two or more nodes into a supernode and apply KCL to that particular supernode. So if I apply KCL to this supernode, okay, what are my currents going to be? So these are now my currents for the supernode. No, this is moving out of the supernode. So this one is 1. This is also moving out of the supernode. Okay, I have another current here moving out of the supernode. I have a current here flowing into the supernode. And then I have a current here flowing out of the supernode. Okay, so that's 1, 2, 3, 4, 5 currents, either flowing into or flowing out of the supernode. So what is this current? This current is VB minus VA over 6. VB minus VA over 6. What is this current? What is this current here? No? That's just VB over 3. No? Plus VB over 3. What is this current here? That's VC over 4. Okay. What is this current up here? That's VC minus VA over 8. And finally, this current is 5 amperes flowing into the supernode. So this is minus 5 is equal to 0. Okay. So I have one equation here. I have another equation here. But I have three unknowns. I have three unknowns. Okay. Taking a look at this, what is the third equation I can form? Anyone? What is the third equation I can form? It's probably staring at you in the face. Albert, what is the third equation that I can form?
Is it VB minus VC equals 6 volts?
That's right. That's right. Very good, no? The third equation you can form is VB minus VC is equal to 6. In other words, this voltage source, sorry. This voltage source constrains the voltage between VB and VC to be equal to 6 volts. No? If I put this voltage source between node B and C, automatically, mapipilitan na the difference between VB and VC would be 6 volts. So that is my third equation. VB minus VC is equal to 6. That is my third equation. Take note of the polarity, no? Since this is plus to minus, then it has to be VB minus VC. So three equations, three unknowns. This is now just a math problem. Okay. If you solve this, so we won't go through the solution anymore. You can actually enter. You can simplify your system of equations, enter your coefficients into your calculator, and tell your calculator to just compute for the solution for you. No? You're going to get VA is equal to 24 volts. VB is equal to 16.3 volts. And then VC is going to be equal to 10.3 volts. So yun yung mangyayari rito. No? Any question? Any question with regard to a supernode? So again, no, the principle that you apply here is that when you group together a group of nodes and treat that as a single node, then Kirchhoff's current law applies. That all the currents entering must equal all the voltages, all the currents leaving. No? The currents entering must equal the currents leaving, or the algebraic sum of the currents flowing out of the supernode is equal to 0. And I can form a supernode to be more than just one node. No? I can form a supernode over two or more nodes. I can combine rather two or more nodes to be a supernode. No? Okay, so here's a simple, this is a very simple problem. Use nodal analysis to solve for the power dissipated by the 2K resistor. Use nodal analysis to solve for the power dissipated by the 2K resistor. Okay. Okay, how do I solve this? No, actually there are several ways that you can solve it. No, okay. One way is okay. This is not an essential node. No, but if you take a look, you might, if this is your reference, you might consider this to be okay. You might consider this to be a supernode. No? This is a supernode. Okay. If this is V of X, okay, what is the value of this voltage here? The value of this voltage here, this is going to be V of X plus 2 volts. That's going to be V of X plus 2 volts. Actually, if you called it V of Y, it's okay, no? But later on, you're going to see that V of Y is equal to V of X plus 2 volts. Okay? And then now, you can apply KCL, no? KCL to the supernode. Okay, what is this current here? Can someone tell me what is this current here? Anyone? Janica, what is that current?
Sir, is it wait lang.
Itong current na to. What is this current?
Is it EX minus 8 volts over 1K ohms?
Very good, no? V of X minus 8 volts over 1K, no? Plus, okay, can I ask Ms. Team, what is this current here? This one.
Sir, Vx over 2k ohms po.
Yeah, that's Vx over 2K, no? So I'm applying KCL to the supernode, no? So what is this current here, down here? Can I ask Lance? Ano yung current na to?
Sir, V of X plus 2 volts over 3K po.
Over 3K. And this should be equal to 0. Okay, that should be equal to 0. No? If I had labeled this V of Y, okay, then this would be V of X minus V of Y over 3K, no? Kasi dati-dati sa supernode, let's say this is V of Y, then this would have been V of X minus V of Y, okay, over 3K, no? Okay, but later on, I'm going to see that V of Y minus V of X is equal to 2 volts. Or V of Y is equal to 2 volts plus V of X, no? Sorry, there's something wrong, sorry, no? V of Y minus V of X is equal to 2. V of X minus V of Y. Should come out the same. Am I doing something wrong here? No, sorry. Sorry, there's no resistor. Silly me. Sorry. If I had labeled this V of Y, okay, if I had labeled this V of Y, then this current is just V of Y over 3K, no? This is just V of Y over 3K. I don't know where I got my previous expression. Okay, and if I substitute V of Y for this, then I'm going to get exactly the same as this. Okay, so I don't know, mental block lang ako ron ng sandali. Any question with regard to this? So actually, kita nyo, no? It's a very simple single. This is just a single equation, a single unknown equation. No? One equation, one unknown, so it's very easy to get V's of x. Okay. Anyway, if you solve for this, you're going to get V's of x is equal to 4 volts. No? Now you're supposed to solve for the power dissipated by the 2K resistor. So the power dissipated by the 2K resistor is just V of x squared over 2K, and you're going to get 8 milliwatts. Okay. Any questions?
Sir, may question po ako.
Yes, sir.
What if yung supernode po ay merong resistor po in series with the voltage source po? Do we still treat it as a supernode po or as separate na po?
If the supernode had ito for example, may resistor in series with the voltage source.
Opo. Nag-drawing po ako sa MS Paint para ma-visualize. Can I share my screen po?
Sure, please. Go ahead. I'll stop sharing.
Okay. Kita na po ba, sir?
Okay.
Ayan po yung example. So previously po, kapag wala po itong resistor na to, we would consider this a supernode po.
Yes,
Pero what if there is a resistance po with 2 essential nodes po yung dalawang yan? Do we consider this a supernode po?
You don't consider that a supernode, no? Actually, the term supernode, you can apply it by combining any 2 nodes, ano? But what I'm trying to say is you should not combine this into a supernode. Because you can get an expression for the current flowing through that, ano? Kasi pag let's see if I can annotate. I should be able to annotate your slide. Hindi ko ma-annotate. Just a while, no?
Sir, would it be parang ganito po?
Yeah. Yeah, because in this particular case, that's that current is VA minus the
6 volts. Ganyan po, sir?
Yeah, you can do that. Exactly, no? You can do that.
Okay.
So you can get an expression for the current exactly how you did. And therefore you can apply KCL at node A.
Okay po. Okay po. Yan lang po, sir.
Yeah, you answered your own question for yourself. Very good.
Okay. Thank you po, sir.
I was going to annotate it exactly the same way. Any other questions? Okay, ito. Here's an exercise. I want you to think about this. Okay. Can you apply KCL at any, first of all, no? These are your unknowns, V1, V2, and V3. Your reference is here in the middle. Okay. So nodal analysis, that means you apply KCL to the nodes whose node voltage you cannot determine by inspection. My question is this: can you apply KCL at any of the nodes? Anyone? Okay, I cannot apply KCL here because I don't know the current here. I also don't know the current here, no? Okay. I cannot apply KCL here because I don't know the current here. I cannot apply KCL here sa baba because I don't know the current here. So it appears I cannot apply KCL anywhere, no? So what am I going to do? To what can I apply KCL? Can somebody give me a suggestion? Yes, Lance.
Sir, I think po pwede po gawing supernode yung V1, V2, and V3.
Yes. That's right, no? You can apply, you can make this a supernode. Okay. As a matter of fact, okay, since this element connects V2 and V3, pwedeng isama to sa supernode. Okay, but let's say hindi natin isasama yan sa supernode, no? So what's my Kcl equation for the supernode? Okay, what's my Kcl equation? I have three currents, no? This one, and this one. And then I have this one going this way, and then I have this one going inward, no? So ano ito? Ano itong current na to? That's just V1 over 4, no? Plus, what is this? V2 over 10. And then what is this? This is V3 over 5, no? So what are the other currents, no? What is this? That's 0.25. But what is this? This is minus 0.25. So actually this cancels, no? Is equal to 0. That's why I was saying sa supernode natin, in our supernode, okay, I can actually include this, no? So this is my supernode. This whole thing is my supernode, including the current source. No? Because if I took the current source out of the supernode, magka-cancel out anyway, no? Kasi you have 0.25 entering one terminal, but 0.25 leaving the other terminal. So it cancels out anyway. So I only have really three terms. Okay, so having said that, okay, let me erase this now. So like I said, this okay, this is equal to 0. Okay, so that's three unknowns. I need two more equations. What are my other equations? What are my other equations? Nika, can you tell me another equation that I can use?
V2 minus V1 equals 8 volts.
V2 minus V1 equal to 8. No? Sige, Nika, tuloy mo na. What is the third equation?
V3 minus V1 equals 12 volts.
Is equal to 12. No? So I have three equations, three unknowns. Okay. So I can solve now for V1, V2, and V3. Okay. Yeah, that's all I wanted to discuss for today. So like I said, I just wanted to give plenty of examples. Okay, next meeting. Okay, so what did we take up now? First of all, we took up the general procedure. Then we took up what happens when you have a floating voltage source. So next meeting, we'll just complicate it a little bit more. Lalagyan natin ng controlled source, and then lalagyan natin ng controlled floating voltage source. So those are the only things, no? Otherwise, it's really just a lot of examples sa next meeting. Are there any questions? None? Good. So that's all. No? That's all I wanted to discuss for today. If you have no more questions, then I'll close the session as soon as the last person leaves. Okay? Thank you.
Thank you po, sir.
Thank you po.
You're welcome.
Thank you po, sir.
Thank you po, sir.